Now that we've taken a good look at the derivatives of calculus and the integrals of calculus, we're ready to bring it all together with what is called the fundamental theorem of calculus. And it all starts by looking at the total amount of change between 2 points. Let's say, just for example, we'll go between x equals 1 and x equals 2 on the function f of x equals 6x. Well, if we're talking about the amount of change, that means this is the derivative. If we want the total amount of change, we need to figure out what those original values were. We're going to integrate 6x dx, which gives us 3x squared plus a constant. Now, if I want that change to occur between when x equals 1 and x equals 2, we can look at when x equals 1. In this formula, it would be 3 times 1 squared plus c, which is just 3 plus c. If I want to know what's happening at x equals 2, that would be 3 times 2 squared plus c. And that's going to be 4 times 3, which is 12, plus c. We want to know how much change happened between them. That means we're going to subtract them. We'll take the top one, the 2, the 12 plus c, and we'll subtract the 3 plus c. Well, if I distribute the negative through, we get 12 plus c minus 3 minus c, which is kind of nice because c minus c subtracts out to 0. And so all that's left is 12 minus 3, which is 9. In other words, the total amount of change that has happened between 1 and 2 on the function 6x is actually equal to 9. Another way we can think about what we just did is when we took the integral of 6x dx, we were interested in the change between 1 and 2. We're going to put those 1's and 2's as limits, as we'll call them, on the integral, meaning we're going to take the integral from 1 to 2 of 6x dx. So when we evaluate that and get 3x squared, after it's evaluated, we'll put a vertical line to the right and say we're evaluating it from x equals 1 to x equals 2. In other words, we're going to plug the top value in first, 3 times 2 squared, minus, and then plug the bottom number in, 3 times 1 squared. And that's where we get 3 times 4 is 12, minus 3 times 1 is 3, and 12 minus 3 is 9. Notice when we had those limits of integration on the integral sign from 1 to 2, we did not worry about the plus c. The reason is we'll end up with a plus c minus c, and those will go away to 0, leaving just the numbers. So if we have integration limits, we're going to drop the plus c and just plug that value in. That process that we just did pulls in what is the fundamental theorem of calculus, which states that if capital F of x is the antiderivative of lowercase f of x, that is to say that lowercase f of x prime is capital F of x, then we will say that the integral from a to b of f of x dx is equal to that capital F of x evaluated from a to b, which means we plug that top number in and subtract whatever that bottom number is. That is the fundamental theorem of calculus, which allows us to calculate antiderivatives between 2 points. That's what we're going to do here. Let's look at some examples where we can use this. Let's say we want to do the integral from 1 to 4 of 3e to the x minus the square root of x dx. Well, we know that square root of x can be rewritten actually as x to the 1/2. That might be better. And then we can integrate it. The antiderivative of 3e to the x is 3e to the x minus increase the exponent by 1 and multiply by the reciprocal. And because we have limits of integration, we're going to evaluate this from 1 to 4. That means we're going to plug 4 in. And we have 3 times e to the 4th minus 2/3 times 4 to the 3/2. And then we'll subtract, plugging the 1 in. 3 times e to the 1st minus 2/3 times 1 to the 3/2 power. And notice those parentheses are very important because that minus sign isn't just subtracting the first term. It's going to have to distribute into both of them. Or I can just type this into my calculator with the parentheses exactly like it looks, and I should get 150.97. Which means the total amount of change that has happened between 1 and 4 of 3e to the x minus x to the 1/2, or the square root of x, is 150.97 units. Let's do one more example. Let's find the integral from 1 to 2 of x squared plus 5x minus 2 dx. Well, we can integrate it to get x cubed divided by 3 plus x squared, and we take the 5 divided by 2 minus 2x. And we're going to integrate that from 1 to 2. Which means we are going to plug in the top number and have 1/3 times 2 cubed plus 5/2 times 2 squared minus 2 times 2. Put all of that in parentheses. And subtract, in parentheses, plugging the 1 in. 1/3 times 1 cubed plus 5/2 times 1 squared minus 2 times 1. And close the parentheses. If I put all that in my calculator, I think I get 47/6, which is approximately 7.833. These are called definite integrals because they have definite limits on the integral that we can evaluate the exact amount of change that has happened using the fundamental theorem of calculus. Our next video is going to look at how substitution plays in to this fundamental theorem of calculus and definite integrals.